So next up, we have to connect velocity and acceleration of functions. If you remember when we were first talking about velocity and acceleration, we said that when the velocity of a function and the acceleration of a function have the same sign, it's speeding up, right? So if, let's say, these are both positive or greater than 0, then your function is speeding up. The same thing is true if they're both negative. If they have the same sign, it's speeding up. If they have different signs, like for example, if the velocity is greater than 0, if it's positive, and the acceleration is less than 0, it's negative, then it's slowing down. So if your velocity function and your acceleration function have the same sign, your position function is speeding up. If they have different sides, they're slowing down. We went over this already. But now we could use all the things that we've covered this unit, all the different pieces that we learned with concavity and with increasing and decreasing, and we could put this into action and we could use it on equations without having to look at a graph. So for example, if we have this function here and we want to see when it's speeding up and when it's slowing down, right? If we're trying to find when it's speeding up and slowing down, this is the same thing as asking when the concavity and increasing and decreasing agree with each other, right? When it's concave up and increasing, it's speeding up, and when it's concave down and decreasing, it's slowing down. So to do that, we're going to have to find the concavity and find when it's speeding up and slowing down and put it all together and see where it overlaps. So the first thing we're going to have to do is find f prime of this function, which is going to be 3x squared plus 8x plus 5. Then we're going to want to find the second derivative, the acceleration of this function, which will just derive this, and we'll get 6x plus 8. Now we want to find our critical points and our points of inflection to see when we're testing. So to find the critical points, we set this equal to 0, and we'll factor it. We'll get 3x plus 5 and x plus 1, which gives us the x values of negative 5 over 3 and negative 1. And if we set this one equal to 0, if we set our acceleration equal to 0, we'll end up with x equals negative 8 over 6. Now if we make a number line and put negative 5 over 3 and negative 1 on it, just like before, to see when the function is increasing and decreasing, or when our f prime function is positive or negative, we'll see that if we plug a number smaller, more negative than negative 5 over 3, let's say negative 2, right? We'll get a negative number times a negative number, so it's going to be positive. If we plug in a number in between negative 5 over 3 and negative 1, let's say negative 4 over 3, we're going to end up with a positive number times a negative number. This is going to end up negative. If we plug in a number greater than negative 1, we're going to get a positive number times a positive number, and it's going to end up being positive, right? So we see that it's increasing from negative infinity to negative 5 over 3, decreasing in between negative 5 over 3 and negative 1, and increasing from negative 1 onwards. And now if we put a number line for our concavity, and we put negative 8 over 6, if we plug in a number less than negative 8 over 6 into our function, we're going to get a negative. And if we plug in a number greater than negative 8 over 6 into our function, we're going to end up with a positive, right? Because it's going to be, let's say we plug in a negative 2 for this side. We'll get negative 12 plus 8 is going to end up being negative, right? Let's say we plug in 0 for the right side, right? We'll get 0 plus 8 is going to be a positive number. So now, to see if it's speeding up or slowing down, we have to see when the acceleration and velocity have the same sign. If you can, just look at these number lines and see where they overlap, that's cool. But you could write it out all on one big number line to make it clearer and make it easier to see. So if we have our two different number lines over here on the right side, we can combine them into one big number line and just put all of the points in there, right? So our lowest value is negative 5 over 3, and then negative 8 over 6 is the same as negative 4 over 3. And then we have our point negative 1 right here, right? We'll put our velocity function up top and our acceleration function down at the bottom to see when they agree with each other. So if you look on our velocity function, we see anything less than negative 5 over 3 is positive. So we'll write that up here. We can see that anything in between negative 5 over 3 and negative 1 is negative. So this is negative and this is negative. And anything greater than negative 1 is positive. Now if we look at our acceleration function, we can see anything less than negative 4 over 3 is negative. So this is negative and this is negative, and anything greater than it is positive. So this is positive and this is positive, right? Now if we combine what we have, we can see that these signs disagree, so it's slowing down. These signs agree, so it's speeding up. These signs disagree, so it's slowing down. And these sides agree, so it's speeding up. So we can say that the function f is speeding up on the interval negative 5 over 3 to negative 4 over 3 and at the end here, -1 to infinity, and slowing down on the interval -infinity to -5/3 and -4/3 to -1. So for this section, all you need to know is that the relationship between the two is if your function is both decreasing and concave down or increasing and concave up. If the signs of the two agree with each other, it is speeding up. And if they are different, if it's increasing and concave down or if it's decreasing and concave up, your function is slowing down. That's it for this section. Anytime you see this, you can make a number line and write it out. And just derive your function twice and run both your critical points and your points of inflection. That's it for this. So we're moving on to optimization.